All right, so welcome back, everybody. Today we are going to talk about Django API views and the Django REST framework. So far we've created Pokemon moves. Yesterday we finished off the week talking about associations and how our models relate to each other in regards to many-to-many, many-to-one, and one-to-one connections. By the end of class, we also discussed a little bit about the Django server and URL paths. And we're going to build off on what we finished yesterday's class and talk about views. So what are views, right? So essentially, views are a functions, as you guys saw yesterday with the triangles, the squares, and the circles. They're functions that allow us to essentially reach some form of uh, or to display data from a request, right? Things to consider when creating our API views is using JSON format. So we can use the JSON.loads to grab the JSON data, but we also have stuff like serializers that's going to allow all this to become a little bit easier. You'll see how this comes into play when working with our views. And then another thing when talking about your views is how you're querying your database. So using filtering or sorting to retrieve the data um, it's going to become more prevalent than it has been last week. Recently, we've been doing stuff like objects.get or objects.aw just to grab, a general data or, one specific item. But we can be using stuff like filtering to grab a large amount of data depending on the criteria that we're adding in there, right? We're going to expand on the URL patterns and how we can link that to our models and create specific endpoints for our Pokemon and moves to be able to grab like multiple Pokemon or a single Pokemon. And I think it actually gets straight into lecture from here. All right, so I believe, let me come back up here. So as mentioned, we're going to be talking about API views. By the end of it, we'll also create some tests to test out our views. And we'll be talking a little bit about RESTful APIs as well. All right, so before we actually dive into the URL patterns, I want to show you guys a little drawing that I created to kind of understand how the URL patterns work and how it kind of connects to our client and our server, and essentially just the flow of it all, right? So here we have our client, and when thinking about our client, we're talking about stuff like React. If you guys use ThunderClient, I think that's pretty new to your curriculum. We didn't use it. We use Postman. But essentially in your client, specifically stuff like React or your actual application itself on the front end, you guys have used stuff like forms, right? And these forms have input fields that take in input from the users. And this specific form here, we see something where we have an input form like Pokemon, level, description, and moves. And the user has the ability to kind of go in here and add certain input for what they want to get. And like everything else, we've seen that we typically have a button. We click this button and it has some kind of functionality to it, like an onSubmit function. So our user here is trying to create a Pokemon, um, or specifically get a Pokemon, right? Or something like that. They can go ahead and put in information and they click the onSubmit. Well, we will set up this button here to, upon submitting it, we run some kind of function. And this is kind of very down and dirty, like grand scheme of things of how it should look like. But essentially, we should have some kind of functionality that whenever we put a submit, we can grab the information that the user is submitting, and we create what we call a request. And this one specifically is a form of a GET request. And you kind of started using this already when you guys were working with React and try to ping other APIs. You put in a request. You have the URL that you are trying to reach, the URL endpoint. Some more complicated APIs might take some form of authorization. They might take some different parameters. Some take query parameters where you can add this extra stuff into the URL pattern, and so on and so forth. That GET request gets sent, and it is received by our Django server. It receives the request, and here we see like a global scope of what our Django project looks on our server. And what happens is our server receives this request. It uses our urls.py within our project folder, which you guys kind of saw yesterday a little bit, right? It uses these URLs to find a specific URL path that matches the URL path within that request. And what would happen here is it will probably have something like Pokemon, right? We will have a path that would link directly to the Pokemon model, right? So that URL will take us to the path, which will lead us to the Pokemon model. And then within that application, it will link us to that application URL path, which will have essentially some form of an API view, right? And this API view, this is a very down and dirty version of what it will look like. Essentially, what this API view will be, it will be a form of a class, and it'll have different methods, right? The ones that we will be talking about today will be like a get method, which is something you guys are very familiar with. And this get method will take in this request, and it uses that request to figure out what you are asking for, right? In this scenario, maybe they ask for a specific Pokemon by ID. We can take that ID and grab it, query the database by grabbing that Pokemon, right? Using Pokemon.objects.get, it's part of Django's ORM model. It uses, ORM object relational manager, and it uses the models and validators to grab what we're looking for. It goes into the database, it grabs what matches the ID, and then it returns it back to you. We can use serializers to serialize that data and then return it back in a response. Right? We send it back to our front end, and then they get their cute little picture of Pikachu and whatever. Does that make some kind of a sense to you guys of how that would work? All right. Well, today we'll also start talking about RESTful APIs, which we'll get to it. But we kind of saw it on the drawing real quick here. Essentially, what is a RESTful API? Well, essentially, RESTful API, the REST standing for representational state transfer, is essentially an architectural style, right? And it's used for designing network applications, particularly our APIs, which you guys are tracking, stands for application programming interfaces, right? A RESTful API essentially just allows different systems to communicate over the internet using HTTP methods and resources in a way that is efficient and most importantly, stateless, right? Some key concepts of REST and RESTful APIs are like the URLs. So essentially in a RESTful API, we have like resources, which could be like users, orders, and products that are represented by URLs, which we talked about Friday, which stands for Uniform Resource Locators. And then we have certain endpoints like maybe /Pokemon, /Pokemon1, which can represent a Pokemon by the ID of one. And it's honestly just the style of how the API is kind of structured, right? And stateless because meaning that each request from the client to the server must contain all the necessary information to understand the process and to understand and process the request. Right, so the server does not store any session information about clients, which is where these statelets come from, right? The request from the client to the server must contain all the necessary information to understand the process. All right, from database to the web server to your actual application, the entire process and structure of how that's built is the sole concept of a RESTful API. All right, so not something that you can kind of just visually see, it's just one thing. It's the style of how it's built and what it does. Do I have any questions on what's a RESTful API? I'm sorry, English is hard, so I am struggling with these big words. Any questions? When it comes to your RESTful APIs, think of your web applications. All right, so all the information we see on our screen is not already loaded in the application. right? It's sent via the post request, and then it's rendered on our screen. All right, so when we open Facebook, a function happens that's making an HTTP request to a RESTful API that's in someone's basement or attic, right? In some building somewhere. Using a GET request with our URL, which can contain different data within the body. Therefore, return to you your post from Facebook. The request gets sent to the server, and then it uses the URL endpoint to manage that request. It uses the views to handle that request and then sends it back to the user. When it comes to our database, we have our different methods, which we will elaborate a little bit more, I believe Thursday, in regards to the type of request it can make. And it might query a database using one of those, which you've heard the acronym probably already, which is CRUD, to get what the user is asking for. And here we have something similar to what we saw here on the TO draw. Essentially, we have our client, our application that puts in a request, and it goes to our server. So thinking back to the analogy of Facebook, grabbing all the posts that a user might have, it could be a GET request that goes to our server. Our server uses its ORM to query our database. And we see here an example of how that would look like, right? Selecting all from posts. It grabs that information, returns that post query set, goes through our server once again through our API view, which is then serialized and then sent back as a response back to our client, giving them all the posts that they might have. Do I have any questions about the GET request flow? Once again, we saw that with the tail draw. Very similar. This one's just a little bit more broken down of how that works with Django. All right. So let's go ahead and actually get into some code today. So yesterday, we saw this here where we came to the urls.py within our project. We saw how we were able to create different URL paths. We talked about admin and how that works, where admin is coming from, and the editing of the URL path. We talked about how path takes in two parameters, one being the URL path and the other one being some kind of function or a view. We created some functions here within the urls.py to demonstrate how that worked. But today we're going to elaborate a little bit more of how exactly we are going to do this with our applications.
When you get a chance, Roger, can you zoom in on one quick, please?
Yes, I can. I should just have it like that permanently. There you go. All right. So what we are going to do is we are going to navigate to our Pokemon app views.py. And we're going to do that first before we work with the URL patterns so you can see how it connects. But essentially, what we just did here in the urls.py, we are going to do for our Pokemon app within a specific file. So we'll go to our views.py. And you already have the Django shortcuts render imported, but we are going to want to import some specific items in here. Move this back over here. Well, first and foremost, since we're creating views for our Pokemon model, we might want to import our model. So we can say from .models import Pokemon. All right, we need to have access to the Pokemon model so we can actually use it. We are also going to import from REST framework dot views our API view, which is going to be a class that we are going to inherit from to create our custom-made Pokemon views. Also from REST framework, we will import from REST framework.response, import response, and for now, we'll also import from our serializers, our Pokemon serializer. One thing about your imports, guys, no one expects you to memorize all these imports. Like, unless you do this day in and day out, the chances of you memorizing every single import, where they come from and what they're used for, are pretty slim. So there is a cheat sheet, which I believe Francisco dropped in the Slack channel. If you're not a fan of that cheat sheet, you can create your own kind of document where you track all your imports. Highly recommend. There's times where I forget the imports too and where they're coming from. So make your life a little bit easier by creating a little cheat sheet, right? So to actually create our view, we are going to make it into a class, and this class is going to be called all Pokemon. This view will be for us to handle how to grab all the Pokemon within our database. And just like I mentioned earlier, we will inherit from the API view module, or my apologies, class. The first method we will create is going to be a get method, which essentially is going to be handling our get request. Within this method, we're going to take in self and the request for this view. Now, let's say they put in this request to our server that they want to grab all the Pokemon. If I wanted to grab all the Pokemon from my database, how can I do that, Ryan?
You would do would it be data first?
We could call it data, we can call it all Pokemon. But let's say all Pokemon just so we can stick to a common naming convention. Right? We're trying to grab all the Pokemon, but we declare the variable. Well, how do we grab all the Pokemon? And it's not a true question. You guys have already been doing this for the past week. Yes, Owen.
Would you do get parentheses and then you'd put in the module or model that you're sending that get request to?
No, right?
Okay.
We're still working within Django, right? We are still working with Django's ORM, right? It's and some of the things that we inherited when we created our model was the ability to run certain queries for a database, right? You've been seeing them for the past week. You've seen it in the shell, right? The module has specific methods that it inherits, and one of these methods that you guys have all used is .objects.all, right? That's how we query our database. We're within Django. We're not dealing with any kind of like URL path for now or any get requests specifically like like actions.get and putting in some kind of import. We're not doing that here. This is just a class of actually how to work with our data, right? I want you to, when you're creating your view, think of it almost like still working within your shell, right? The same commands you use in your shell, your Django shell, you can do that here, right? Because you're using the model, and the model itself has methods that inherit from models.model. Those being the query methods of objects.get, .filter, right? The full cleans, the is valid, all those same methods that we've been using within our Django shell, those are still usable within our views. So to answer the question, to grab our Pokemon, we would call the model and say Pokemon.objects.all. That'll return to us all the Pokemon within our database, right? And the reason why we've been doing the shell and using all these commands is to build up to this point of working with these commands in our views. Does that make sense to all of y'all? Awesome. I know the admin side is pretty nice, right? But it doesn't do you much use when you start working with the views. So as nice as it is, it's important to know how to use these query parameters or querying, right? So this all Pokemon variable should now hold all our Pokemon. And what we are going to do is to return our Pokemon in a form of a response. So to do that, where my mouse at? We'll use the response that we imported from Rust framework, and we can say return response, and then we will return all Pokemon. And then it'll be dot data, I believe. Now, one thing about the Pokemon.objects.all is that they're what did we forget to do to all Pokemon?
Do the many equals true or something like that?
You're on the right track.
Yeah, I don't know.
What have we been doing whenever we were grabbing data? We queried the data, right? It's in a form of a query set that's coming from Django in Python, from our
Serialize it?
database. We have to serialize it, right? We have to serialize it. So what we can say is serialized all Pokemon is equal to Pokemon serializer. All right, Pokemon serializer. We can add all Pokemon within here. And then we can say, just like James Byers brought up, many equal to true, right? Because it is a query set, right? It is a query set, so we need to let our Pokemon serializer know that there is multiple of them in here. And then let's go ahead and refactor this to say serializer or serialized. I don't know. I'm just being picky here. Serialize all data. Okay. And let's see how this works. So as of right now, we have a view for getting all Pokemon, but nothing is really connected here. So now that we have this view, let's navigate back to our Pokédex project urls.py. All right, we had some paths here that we created, which is squares, circles, triangles, so on and so forth. And we are going to add a new one, which is going to handle the path, the endpoint for our Pokemon. We add comma after the last path, and we open up a new path here. And the path that we are going to use is going to be API /v1 /Pokemon. Roger, where's API and v1 coming from? Well, API and v1 is kind of a common practice. One API standing for the fact that this is for our API, and the v1 being the first version of our URL endpoints, right? If you've kind of paid attention to some of these APIs that you guys have used, you might have noticed that there's probably like a v2, v3 within the URL path, and that's just saying that's a more updated version. But by adding v1 in here, it allows us to create other endpoints, a much updated version, without completely removing the other versions and making it obsolete, right? It allows our websites to use these specific endpoints for a while before they're no longer useful, right? So allowing us to make updates and changes and come up with new versions, right? And then after that v1, we're going to create the Pokemon endpoint, right? Pokemon /, right? Don't forget this /. And just like Friday, we mentioned that our path took two arguments. One was the URL path, and the second one was some form of a function. And we know that our views are a form of function, but we don't want to add our Pokemon view directly within our urls.py of our projects directory. Why do you guys think we shouldn't do that? Also not a trick question.
Is it because we're hard coding it in?
No. It kind of goes back to like the separation of concerns. We are going to have different endpoints, whether they're Pokemon, moves, maybe they trainers, maybe food. Depending on how complex our application might get, we're going to have different endpoints. And for every single one of these endpoints, we'll have even additional sub endpoints. Think about Pokemon. We might have like a Pokemon endpoint, but within those endpoints, we can grab all Pokemon. We can grab single Pokemons. We can do some form of query endpoint where we can grab like multiple different Pokemons. Essentially, these endpoints just get longer and more complex as we go. And it would make sense that we would probably want to separate where these endpoints are located at just to keep everything organized, right? And to do that, we have to use something called include. And to get include, we have to go ahead and add it from our imports up here where it says Django.urls import path. You're also going to import include. And what include is going to allow us to do is add a specific location from where I want to include my URL paths. What I want to include is going to be the Pokemon app.urls. So instead of giving it a direct view here, I'm going to essentially reference my path somewhere else. As of right now, the Pokemon app.urls does not exist. So within Pokemon app, I'm going to create a new file and call it url.py. Right. So within my project, I have my urls.py. I have these endpoints. I have one specific endpoint that's leading me to Pokemon, and it's referencing the Pokemon app.urls. So essentially, if someone tries to use the Pokemon endpoint, once it gets past this, it's going to reference the Pokemon app.urls to continue that URL path. Make sense? Do I have any questions so far before I move on to the urls.py within Pokemon app?
Just to clear things up, so you'll have a urls.py both in your project directory and your app directory.
Yeah, right. So going back to this description, right? When that request comes here, it goes to my Django server. It goes into my urls.py. This urls.py is within my project, right? The project.urls.py. It looks at the paths that I have, which we just saw here. It looks at this. It looks at all these paths. It's going to look for something that shares that similarity of Pokemon. It's going to look for this, right? And it's going to find it. But when it finds it, it's also going to find this, which is going to say include. This, therefore, essentially routes it to this urls.py within my Pokemon app, right? So it goes from the project urls.py to the path section, which reaches and includes, routes it to my app. From my app, it routes it to the urls.py. And then within this urls.py, that's where we will link our views. Make sense?
It does. Thank you.
It's doing the exact same thing, kind of, but with extra steps, just linking it somewhere else. All right. So I will keep this open just so you guys can kind of see if you guys would like. But we have the path here for our project, and this is the urls.py for our application. Once here, we are going to do from Django.urls import path. All right, we're going to import paths so we can create our own paths within this file. Who can take a wild guess of what we're about to declare here? Gary, looks like you have the answer.
I do not, but if I had to guess, it would be the Pokemon API.
Yeah, a little bit more specific. We're going to create this. All right, we're going to create some URL patterns within this urls.py. So we're going to go ahead and declare URL patterns is equal to open and close brackets. We're going to use that path module that we just imported, or the path method, to open up a path. The path is going to be an empty space, which we can talk about in a little bit. And then we are going to pass in, just like we did here, where we pass in a URL path and a function. We're going to pass in a specific function here, but in our case, it's going to be a view, right? Here, these are just direct functions. Well, our code, instead of just making it into functions, we are grouping them all together within a class to make our code much nicer, right, and more effective. So this is a view, right? It's inheriting from the API view. So what we are going to do is go ahead and bring in our all Pokemon. So we'll say from dot views import all Pokemon. Within our path, we're going to say all Pokemon dot as view. So this method here allows us to discover information about the view when the URL reverse looks up, user breakdown duration. Let's go ahead and open this up a little bit. Essentially, what this is just telling the path is, hey, this is a view. It's not just a regular function, so treat it as such, right? Treat it as a view. And essentially, it'll run the methods that we define within it. All right. Depending on the type of method that is being used for that request. All right, so it's smart enough to be able to see the request and route us to the all Pokemon.as view, and then getting in there, depending whether it's a get, post, put, delete, it will do as such. So what this is going to look like within our server will be something like http:// I don't know the numbers to it off the top of my head. It'll be something like this, right? Some random numbers. I don't know it from memory. Let's just do this. And then it'll be API, V1, Pokemon, and like that, right? This is essentially the path that is being made here. Now, once we start adding other paths, we will essentially elaborate a little bit more about what comes after the all Pokemon and why this is empty. But essentially, this path here should be able to return all the different Pokemon within our database. So we have the path, we have the as view, and then we are going to add one last theme, which is going to be name. All right. And this specific argument is going to come in handy once we start creating our tests for our views. Right. So as of right now, this doesn't really mean too much to you guys. But essentially, once we start talking about tests and our views, it's going to use this name to create the URL path for the test. Right. Just know that you want to have this for testing purposes. All right, we've done a lot of coding. Let's go ahead and run this and see if it even works. So we're gonna go down here to our terminal. We're gonna say Python manage.py run server. And I have something wrong here. I do not have my environment open. I'm gonna say source. I believe it's this one. And I'm not within the same directory either. Give me a second, guys. There we go. Let's run it. Awesome. I can go ahead and open this in the browser. And I can come here and say API v1 Pokemon. And there we go. It worked first time. Awesome. All right. So I go ahead and I put in my the URL path that we created. And we see here that a GET request was created. We got a response of 200. And the response also gave me back my data. All right, Squirtle, Charizard, we have Pikachu. Just like our dot views specified, right? It put in that GET request, it queried all the Pokemon, it serialized them, and then returned the response of serialized all Pokemon, resulting in this nice request. Do I have any questions of how we reach this point in our view?
Could you pull up the URLs.py?
I'm assuming you are trying to see the one for the Pokemon one?
If I could see both of them.
Yeah, of course. There we go. Nobody has any questions. That's okay. All right, let's go ahead. Move on with the class. So we have all Pokemon. We have a view that was able to return the all Pokemon. Pretty awesome. Who can walk me through how to do this for our moves? I like your enthusiasm, Jacob. Thank you. So start us off, please.
Oh gosh. Yeah. Let's see. So for moves, trying to even see where I would even start.
It's okay. I'll start you off, and then you can take over. Right.
Okay.
So very similar to how we had the views for our Pokemon. I'm gonna go ahead and copy this real quick. We are going to go to our Move app, and then within our Move app, we'll navigate to dot views, and then just so I don't have to repeat myself on the imports, I can just go ahead and copy this in here. And now you have something to kind of work with. So how will we do this?
Let's see. So can you jump back to the other views just really quick?
Yeah, of course. Let's actually open it up sideways. I don't expect a full answer, but just kind of like tell me what, like, around what ballpark we're looking at here of what we're doing.
Okay. So I guess would we create a class called like all moves, I guess. And we'd do like a API view. just like that. Wait, are the moves are included underneath Pokemon, right?
Come again?
I said the moves, like it's underneath like the actual Pokemon, right? So, yeah, I'm not even
Well,
sure where to really start
I
to get
mean,
this.
depends, right? So the Pokemon return to us the moves that they have,
Yeah,
right? But we should have also an endpoint that can return all moves that exist within our API, right? The same way that we just created an endpoint that returns all Pokemon, I want to create an endpoint that can also return all moves. Very similar to how the Poke API worked, right? How it was able to do something like moves and it returned like all this different stuff, right?
right.
Uh, we have one for Pokemon. Let me see if I can find the queries for it. Right, this endpoint right here, right? So it kind of resembles what we're kind of doing right now, right? We have
Right,
like
right.
the actual application, it's API, this is the second version, and they have an endpoint called move. This one specifically returns an ID or a name, but they're probably ones where it returns all of them, right? So that's just like kind of what we're going here for. And same thing with Pokemon. Pokemon has something very similar to that, where it was like API version 2, this is ability, and so on and so forth. But yeah, so using that information, you're on the right track. We probably do want to create a class for this, right? We will probably do a class called moves,
Yeah.
right? Which would inherit from the API view. And now kind of talk me through how you would you create this. And disclaimer already, it's probably gonna be very similar to the all Pokemon one, right?
Yeah. Yeah.
But let's go ahead and create that. Kind of talk me through it and try your best not to look at this. Kind of think like, how would I do this logically? If I was working with my Python shell, right, the Django shell, how would I be grabbing these moves? How would I be converting these moves to how they need to be formatted, sending this back to the user?
Okay. Well, we'll have to do a get method, like something that's gonna grab it. And we'll have to look at self and yeah, do a request. And then if we want to get the specific moves, we'll probably just do like a variable named moves and set it equal to yeah, it would just be would it be moves dot objects or would it still be considered under Pokemon?
It's its own thing, right? How do we grab like all moves? How do we grab individual moves whenever in the shell? Let me refresh your memory a little bit. We can come here and let me move in here. Source, EMBS, Poke. Right, we said Python, manage.py, shell plus. And then we did like all moves, move.objects.all, right? It's the exact same thing, guys, right? We can
Gotcha.
print out all moves. We're doing this, but within our views.
Okay, so yeah, we could just do all moves equals moves dot object dot all, and then we'll have to serialize it, right?
What's happening here?
Uh, that it doesn't recognize that.
Yeah,
Yeah, James, if you want to jump in and help.
You got the import move.
No, yeah, that's what I was gonna say too. That needs to import moves,
Yeah,
not Pokemon.
Okay. Yeah, that makes sense.
move serializer. All right, hey, I appreciate that. Good start.
Yeah.
Who wants
It's
to
Monday
take it on from
morning.
here? It's okay.
Is it possible to serialize it right there on one line, just like it does in the curriculum?
Yeah, we definitely can do it just like this. We could do move serializer and then do it like this. I wasn't looking at the curriculum. If it does, that's great. I was doing it this way to kind of show you guys what's happening at every step. Like first we grab it, then we serialize it, so on and so forth. But yeah, we most definitely can do that. And we saw me do this and the shell plus last week, right? So we can definitely serialize it around it. What else do we have to do to move serializer? We added the move query set, but it's a query set, right? So what do we have to do to the set of queries?
We need many equals true.
Yeah, many is equal to true to ensure we serialize every single thing within here. And then now that we have our moves, what do we do, guys?
Return.
Return response of the serialized moves.
Yeah, we're gonna return our response. And within this response, we're gonna have all moves dot data. Right? Dot data, just like how we did here, right? When we import or from move app dot serializers, import moves serializer. Serialize all moves is equal to move serializer, and then we can add the all moves in here. Data or many equals true. What do you mean it's not defined? Oh, my bad. Right, we grab all moves, but it returns this, right? Remember, we were grabbing this information, but it wasn't exactly what we wanted to, so we did dot data, and it gives us the data in this essentially dictionary, kind of, right? And that's what we're doing here. We're doing all moves dot data. So we have the API, I'm sorry, the GET request, API view for this GET request. Now what's next? Can we just go ahead and grab it? Not exactly.
You
We
go
need
to project.urls.
Yeah, we go to project.urls. And that should be right here. Right, we're back within the main urls.py file within our project. And we probably have to link the moves urls.py. So path. Very similar like the other one, API v1 moves. I do include. And what do I include in here?
The move underscore app dot URLs.
Correct. Move underscore app dot URLs. Right. That'll link my urls.py from move. Let's close up some of these. And that's not one of those files that gets automatically created. We kind of have to do that ourselves. So we come here, we say new file, and we call this urls.py. Within here, we have to import the path. So from Django.urls, import path. And we're going to import from .views, import move. I think that's what we called it. Yeah, moves, my bad. There you go. Okay, someone walk me through how to do the path.
You declare your URL patterns as a list.
Correct. URL patterns is equal to open and close curly brackets.
And then you do path, open, close parentheses, and then do empty quotes, comma, moves dot as view, and then open, closed, and the name equals. That's pretty subjective, isn't it? Or is it? Do you have to declare?
As a matter of fact, let me change the naming convention of this. I'm gonna call this all moves. All moves. All moves. All moves. There you go. It's all gonna be called all moves. The name, I don't think it has to be like verbatim, but you kind of want to make sure you know what it relates to, right?
But
yeah,
you
this-
said that's for the test, so that way you
Correct.
can make sure the pathing is right when you're doing your test.
Correct. We will see
For
that
the routing.
today. The last thing we'll cover today, but yes, this will create a URL path for our test to use. So we now have our endpoint. Let's go ahead and run server. Ah, shoot. No. I closed it. All right. So here we had API v1 moves, and we now have all the moves. That API endpoint worked perfectly. The code worked perfectly. It grabbed everything we were looking for and it sent it back to us. We see a list of objects of individual moves: scratch, thunder shock, flamethrower, and rock smash. Right? Exactly what we were looking for. Do I have any questions on this, guys? Is there? Yes, Owen.
Getting ahead of myself, but when are we going to get into how to link like this page with a React.js interface?
You have already have. You already have, and you haven't
So-
even noticed it.
So on this page, this would be included in your route on the React.js.
In your React application, right? You the same way that you were pinging all these APIs, that's exactly how you ping your own backend, right? If you wanted to grab the information for whoever your users are, you would ping your backend endpoint, right? I currently have a database that hosts tables for Pokemon. It has real data for Pokemon. I just pinged it and grabbed information for it. You would add this URL path and your axios.get. Axios.get, add the URL path. We'll talk more about parameters and authentication later, I believe this week, where you will see how that works. But like, that's as simple as that. You guys have already done it. So that's exactly how that works and how you would essentially use your backend with your front end.
Gotcha. Thank you.
No problem. All right. So we saw how to create an endpoint for all moves. We also saw it for all applications. I'm sorry, all Pokemon. Next, we created the endpoint as well. Do I have any questions so far about how this works? All right. We're gonna take a 10-minute break. It's time. The time is 9:54. I need you guys to return here at 10:04, and we will continue with today's lecture. All right, welcome back, everybody. So we went over creating views for our Pokemon, all Pokemon. And one thing I kind of want to retrace my steps a little bit and talk about the views and how to handle the response. So we saw here that right off the bat, I imported what is response from, where's it at? Response from the REST framework response. And there is a way of doing it, but the reason why I did the response and why it's also later in the curriculum is because this is more the ideal way of doing it. Another way that you can see, which is very common amongst other frameworks as well, is using JSON response. So essentially what we would do is we would say from Django.http import JSON response. All right. Essentially, this will do the exact same thing. The only difference with this one is that this will have to take in a dictionary, right? Whereas here we have our serialized Pokemon. What would happen here is we would have to wrap it within a dictionary. So this will be JSON response. And then this will have to be something like this, where you would put it in a dictionary and then probably do something like Pokemon. All right, it needs to take in a dictionary to convert it to JSON to grab the information. And then when using this, we can go ahead and bring it back. And I can send this again, and then we get something like this, which is essentially JSON. We have an option to use preprint, and we get this, right? So this will work just as fine. The reason why we use the other one is because it's coming from REST framework, and REST framework gives you that nice little interface. Let's go ahead and kind of backtrack a little bit. And we send this, and we see here that we get the interface from REST framework, and it's nice and formatted. It's telling you the type of HTTP response you got, right? The type of method it is, the URL endpoint. So it's a little bit more, it's nicer, right? Better quality of life. So both will work. One is showing you to show you how it's done without REST framework and what REST framework can do for you. So either one will work. I recommend doing the response one, not JSON response, but you have both access to both of them. Also, the way they take in the data is a little bit different. JSON response takes it in a dictionary to make it JSON. The reason why that's done is because JSON is very popular. It can be converted into, it can be used with most different types of languages out there. Yes, Owen.
You go ahead and finish what you're saying before I ask my question.
Yeah, I mean, I would just finish off saying that, JSON is very popular and it can be easily converted into other data format types, which is why JSON response is a thing. But REST framework does provide you with its own response class, right? So you can use that and it provides you with this. So either one will work. It's just how you use them and what it gives you, right? Go ahead, Owen.
So you'd still need your serializer if you're using JSON response instead of just response, correct?
Correct. The
And then-
serializer, although it helps you unpackage it, and I didn't dive too much into it because the serializer, although it does make it into a form of an object or dictionary, which the names are interchangeable between JavaScript and Python, Django has a specific name for it, and I did not want to confuse you guys with that name. But essentially, you still have to use a serializer. The serializer just kind of puts it in a format that's easily converted to JSON, where they're practically the exact same thing. The structure is the same. They're built very similar as an object, right? It's still like a dictionary, but it's not technically a JSON, if that makes sense. So you will still require that JSON response or the response method that comes from REST framework. Does that make sense to you, Owen?
Yeah. And then I'm assuming your front end will still handle it the same way. There's nothing extra you have to put in, whether it's response or JSON response. It's just the formatting of the data, whether it's in a dictionary or a list of dictionaries.
Correct. They will both end up being a JSON, right? I don't say JSON object because the object is in the word JSON. But yeah, they'll both end up being JSON.
Cool. Thank you.
Yeah, no problem. So we can go ahead and continue from there. I just wanted to kind of cover that real quick before we moved on. So we covered how to grab all Pokemon and all moves. Now let's figure out how to do it if we wanted to grab a specific Pokemon. So we already have the URL path that leads to our Pokemon.urls. So we don't need to go back to these URLs on the project. We can just work within our Pokemon app URLs. Here, we have that one path that leads to all the Pokemon. But now let's go ahead and add another path that's going to specify which Pokemon we want to grab. So once again, we're going to add a comma after the path. And I can't stress the comma enough. I say that specifically is because so many times it's happened where you're not getting the path you're looking for because you forget a comma. That comma will mess up your entire path. So don't forget that comma, guys. It's kind of annoying to debug sometimes because it's hard to find that issue. So we're going to come here. We're going to create a new path. And then what we are going to do is add a URL path that's going to be, I believe it's ID. Let me just make sure before I give you guys the answer. I don't see it in the curriculum, but we can still cover it. right, so we have that, we are going to do single Pokemon. And what this single Pokemon is gonna do is gonna be something like this, where we are going to say int and ID. And I believe we saw it a little bit when we were talking with our class on Friday, where we created right here, the triangle. We're able to add some kind of arguments within our URL path, where we were able to add an integer type to take place of whatever is supposed to be of height. Right, so we're gonna do exactly that, but with our Pokemon ID. Right, so we say ID, right, of type integer, and then we add a / here. Right, this is gonna take a view, which we will create within our all Pokemon. And this is going to be its own class, guys, right? So you want to separate this in classes. So for example, if you have all Pokemon, that should be within its own class. That way you can do, get requests, a post request, all within all Pokemon. Single Pokemon should have its own class, so it can have its put request, post request, delete request, so on and so forth. So we're going to create a whole new class for this one. And this is going to be called single Pokemon. And it's going to inherit from API view. And then let's go ahead and put path for now, so we don't get error. And then within my URLs, I'm going to go ahead and import that single Pokemon. And then give in the second argument, which is going to be single Pokemon dot as view. And once again, add a name for testing purposes. And this will be single Pokemon.
I have a quick question on the name again. So, sorry if I'm interrupting. I didn't realize I didn't raise my hand, but does that have to be the same name as in your project dot URLs, that path? So like in your project URLs, you have the path where it's like API v1 move, like, yeah, like in line 41 moves would be that path. Does it have it? I'm assuming it has to be the same exact spelling as moves if you're to do when you're doing your path for your app dot URLs dot py.
And not necessarily. So this prefix of Pokemon and moves, we make it plural to signify it covers everything around moves. Pokemon is already plural, right? The name Pokemon itself is plural. These are all prefixes, right? And then all these URLs that we create here will have the prefix of API back / v1 / Pokemon. Right, so all these paths we create here will all have the exact same prefix. It's just what you follow up after the Pokemon. If you just add Pokemon / and nothing afterwards, then it'll select this URL path.
I was saying for the name equals all Pokemon. Yeah.
Oh, name equals.
Or single Pokemon.
Okay, I understand. Yes. So essentially, it's not going to restrict you to make it to be exactly like single Pokemon. The naming convention you create there should ideally match what your view is, so it's easier to know what you're referencing, right? That's why I'm calling it single Pokemon, because I know this belongs to single Pokemon view, right?
So that name equals has no correlation to your project dot URLs
No,
path. Okay, thank you.
no problem. So we have path, we have single Pokemon as view, and we have a name for testing purposes. Now let's actually do something within our single Pokemon. Well, we are going to define a get method. So define get. Just like before, it will take self, request, and this time we're going to pass in a different argument, and it's going to be ID. Right? ID. This get method should be able to take a ID, which is going to be grabbed from the URL path. Right? So this is accessing the information that comes from the request. Okay? If an ID is added into the URL path, to grab it, it has to be passed in as an argument. Make sense? Within here, I'm gonna go ahead and I'm gonna create a method to grab all Pokemon. Essentially, what I want this.
Can you repeat that real quick, Roger? What you just said last?
Yeah. So whenever this get method runs, it's being called by the request, right? That request is, it has a URL path, it has data, right, within the body. If you want to access something that's within the URL, it has to be grabbed by here, by the arguments, right? I can't say like request.id because it won't know what it's talking about, right? I have to grab it by adding it here, right? The method, the get method is going to grab that URL path and anything within it, right? And we can elaborate a little bit more on URL paths in a little bit. Just know if there is a item within your URL, like an argument here, like we have here, an ID integer type, to grab that, you have to pass it in as an argument to grab it. Right. And as soon as we do this get method, I'll show you how that's working. So once this get method runs, what it should be doing is something like this, where it's going to select all from Pokemon where ID is equal to ID, right? It's saying that the ID table is going to reference this. Make sense? So we saw it kind of like that here, where we did Pokemon.objects.all. But here, it's going to be a little bit different. How do we query a single object, guys? We know how to query all objects, but how do we grab one?
Object.get.
Object.get. Awesome. We're in the right mindset here. Pokemon.objects.get, where ID is equal to ID. Right, that's going to grab my Pokemon. I can say serialized Pokemon is equal to Pokemon serializer. And I'll add a single Pokemon. Do I have to do many equals true? No, I do not, right? It's not essentially a query set, it's just one query. So there's not many within it, it's not a set. So I just have to add that serialized Pokemon should only take one Pokemon. And then we can return response single Pokemon.data. All right, let's come back here. Now we can do an ID after the Pokemon prefix. We'll do ID of 1. And I am getting an error. It says Pokemon object has no attribute data. Why are you telling me that? Oh, I see why. My apologies. I added
This is supposed to be a serialized Pokemon.
correct. Serialized Pokemon.data. There we go. We send it again. And we now see that I got that one specific Pikachu Pokemon with the ID of 1. We can say ID of 3, and I get Squirtle. ID of 2, I get Charizard. Let's look at the inspect tools. We can come within the network. Let me go ahead and send this request again. And we see here that it's making some requests here. And notice the 2, right? Because this is, we are trying to grab ID 2. That's the request we're making. I can click this. On headers, I see the request URL, the type of request, and the status I got back. Right. That request, right? This is right here, request URL. This is the request. Right? This is the request. That request is being handled here. The get method grabs the request as well as the URL. Right? The ID, it's grabbing it from the URL. So we have to add it here as a parameter. Now, we will talk about how we will give in more data that is too much to be added within a URL. But essentially, when we add data into our request, it'll be found within our I want to say it's response. It'll be found here, but right now it's empty. Yeah, right now it's pretty empty. We see a bunch of other stuff that doesn't really matter right now. But yeah, makes sense. The request itself has the URL. The URL has the ID. That get method handles the request, so therefore it has access to the arguments passed within the URL. Do I have any questions about how to query a single Pokemon? So far, so good. Yes, James.
Sorry, I just got a little confused again by looking at something on the, so it's the URLs.py in the Pokemon app. When you set the name as single Pokemon, what is that referring to again, or what is that setting?
Yeah, okay. I'm getting this question a lot, so I'm assuming there's some confusion here, right? The name, it's okay. There's nothing wrong with it. I want you to think of it as how related name is added within our relationships fields, right? Think back to the models. How was the other model able to access the relationship? Well, we added related name, which therefore it added a field that we can access to grab that relationship, right? That's kind of what name is doing here. It allows our tests to be able to grab and access our URL path. The name argument is strictly for testing purposes. This will still work.
Okay.
This will still work if I don't add it. Okay. Once again, the name is strictly for testing purposes, and it'll make more sense once we actually start making the test today, where when we create a URL for our test to test out, right?
Got it. Sorry, yeah, I
No.
was just getting confused because it was the same as what you named in views.py, like the single. I thought it was like relating to that.
No, I mean,
accidentally or something.
this
Yeah,
could be a Pokemon if I want it to be.
right.
I'm
Got it.
calling it single Pokemon because I know it's supposed to be for my view of single Pokemon, and it just helps me remind myself like what it's referring to, right? So the name is strictly for testing purposes. Now let's go ahead and move forward. So this is cool and all. What happens if we try to do? So we got Charizard here, but what if we add Charizard in the URL path? Well, it's not going to work, right? It says that the page was not found. It says that it used the project.urls. It tried the URL patterns in this order. It went from my project URLs. It grabbed admin, squares, circles. It couldn't find it. It got to Pokemon. For all Pokemon, it found the Pokemon in ID. It found the moves URLs, but it did not find a URL path that could handle the string of Charizard. Well, that's because the way that our view is set up right now is only to handle an ID, right? So what if we want to be able to take in the actual name of Charizard? Well, now we are going to introduce something called converters. And what that does is essentially allows us to add here an integer or a string, whatever we add in here, and our converter will be able to use that to convert it into a string or into an int type, depending on what it finds. All right, we're going to use the converters to handle that. Before I move forward, there's something I forgot to cover, and that's how to query for a Pokemon. There is a cool way that we can use, which I believe is in the curriculum, so I'm going to cover it. Right now, we're using Pokemon.objects.get to grab an ID of the Pokemon to grab a Pokemon. But there's another way that we can use that we can bring in from Django shortcuts. So from Django shortcuts, after render, I want you to do comma, and then you're going to do get object or 404. And it does exactly what you think it does. Right? Instead of using Pokemon.object.get and then try and grab an ID, we can use that shortcut that we imported, get object or 404, and then we'll pass in two different arguments. The first argument it takes is the model that it's supposed to be querying, and then what the condition should be. In this instance, I'm trying to grab it with the condition of ID equaling to the ID of the URL path. And now what that does is we see here we got some this page. By adding 1, I get the Pokemon, but what if I add something that does not exist, like 10? Instead of giving me that huge error page, I get still the REST framework page where now it gives me something a little bit more neat and compiled, and it says detail not found. Right? So it gives me a 404 error. Notice here, HTTP 404 not found. It still didn't work, but it gives you a much better description of what went wrong. Right? By adding that get object or 404, that lets you know when you get this page, hey, like where did my project go wrong? Well, it went wrong here, where it tried to grab a Pokemon and it wasn't able to. And if it returns a 404, that means they couldn't grab the object successfully, therefore letting you know either the object does not exist, right? Honestly, that's all it really means, that the object doesn't exist. If it couldn't find it by the ID, that means there's no Pokemon with that ID within your database. Therefore, it returns that 404. So get object or 404 is a nice little shortcut that you can use to kind of get a better idea of where your code went wrong when trying to query something from your database. Make sense, guys? Awesome. Now, going back to the converter. I'm sorry, I kind of gotta go through the curriculum quickly and then I forget what I have to cover. So we have the get object or 404. Now, let's talk about actually taking in a string input. So we are going to add a converter. So within the Pokemon app, I'm going to create a new file. And I'm going to call this converters.py. Within this new file that I created, I am going to create a converter, a class type, and it's going to be called int or string converter. Now, the way that we build this class is actually very specific, right? It's one of those things where, like, if it's not named or built the way that Django wants it, it won't work, right? It requires two specific methods. One of the things that it also requires is the regex for it. Let's see if we can actually open this up and see the documentation real quick. We can say Django converters. Here we go. Very specific to how they want it, right? Notice how it takes the class, right? The name, and then the regex, right? Regex, 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 right? After the regex, it's going to take two methods, two Python and two URL. Very specific, guys. We have to create a method that's going to convert a specific value into Python, and it's going to check whether it's an integer or a string type. And then the other method is going to return that value to the URL. So the regex, I already have it here. It's going to be like that, where we are going to look for numbers 0 through 9, where it's 1 or more, or I want A through Z, 1 or more. Notice we don't have to import RE because it's a converter, it already knows that it works. All right, then we create our method called toPython of self, and it's going to take in a value. And then we do if value dot is digit, right? We're checking if it's a number. Then I want to return value, but I'm going to wrap it around an int wrapper, therefore converting it into an integer. If it's not a digit, then I want to return the string version of what my value is. The next method is toURL, where we take that value and just return it in a string format. Right? Because we can convert an integer into a string, right? We know that we can make a number into string. It's still a number, but in a string format. So here we check whether it's digit or if it's not. If it is a digit, then we have to return it of type integer. If it's not, return it of type string. And then we take that and return it. Now to use this converter, we're going to go back to our URLs for our Pokemon app. And we're going to import our converter. We're going to say from.converters import int or string converter. And now we have to register our converter. To register it, we have to import something from Django.url called register converter. Then we have to use that register converter method. This method takes in the converter that we created, our custom converter, and then what I want it to be called when using it in my URL path. So just like we have something here called int, we are going to create something called int or string. And now that we register that converter and assigned it this alias of int or string, we can use that here. And instead of int, it's going to say int or string. Everyone still with me of how to register a converter? Awesome. So we have our converter. Now we have to refactor our code a little bit to ensure that it's doing what we want it to do. Right now, it's only grabbing an object if it's an ID, but we need to give it the option to take an ID or a string. So what we are going to do is we go ahead and just comment this out, keep it here for the notes. And we're going to say if type of ID is equal to integer, then I want to get the Pokemon by the ID. Else, I want to get the Pokemon by the name. Right? The converter will know if it's an integer or if it's a string, convert it, therefore giving us access to being able to grab it by the name. And then let's do single Pokemon because it's not liking my naming conventions. There you go. Single Pokemon, there we go. Now we can come back to our Django server. Let's go ahead and grab Charizard. And then add the string in here. And it says not found. Why do you think so? Who can guess why it's not finding Charizard even though it's a string? It's something small within our code.
Is it the regets?
No, it's not the regex. It has to do with a name.
Is it
Do
case
ID need?
sensitive?
Your single Pokemon isn't.
Case sensitive.
Ca-
Case sensitive. If you notice when we were creating our Pokemon, they're all in capital letters, right? For the first letter. So we'll have to do dot title. ID dot title, assign that to the name. We come back here, send it again, and it now gives us chart order. The regex was doing what it was supposed to be doing, but we didn't set it for the first letter to be capitalized. Now we can either do dot title within our view, or we can just come back to our converter, and then fix our regex where this would be at the start, it has to be a capital letter, and then everything afterwards can be lowercase. Whichever method you decide to go with will both work. Do I have any questions about converters?
What is that pipe symbol doing up there in your regex online too?
Pipe stands for or. Think of JavaScript when we use like and or. For and, we use the ampersands. For or, we use double pipes, right? In regex, all you need is one pipe to give you or.
Gotcha. Thank you.
James?
Where is it, getting, sorry, I'm trying to explain this, we're feeding it either an ID or a name, and where is it able to tell, like, when we feed it a name, how's it able to still get the ID from the name? Like, where's the logic for that? Is that making sense?
Are you talking in regards to views, like right here?
I think so, like line 26, we're just saying name equals ID dot title.
Yeah, that's the alias we gave it here. We could say, well, it has to be called ID here because that's how we defined it here, right? We could say single Pokemon if it makes it easier for you to understand. And then up here, we want to grab the single Pokemon parameter from our URL. And then we can change this to single Pokemon. And then change this to single Pokemon. And then once we run this, it'll still work. We got Charizard. Let's get Pikachu. And then grab Pikachu. This parameter is grabbing that part, whatever this is called, from the URL path. Right? So whatever you call it in the URL path, that's what's gonna grab. Make sense?
Right. Yeah, I think I was getting confused again because it's grabbing the whole object, not just the ID or just the name.
Correct.
Right. Okay.
No problem. I should have been better with my naming convention. Any other questions, guys? I think I saw someone, I think it's Tristan. That you had your hand raised?
Oh, yeah, sorry. I was asking a quick question on the regex of what the plus means. I assume that's just the same as global, so it can look for more than one occurrence.
Yes, it's one or more. Correct.
Okay.
Regardless, both these have one or more, so it needs to find something, whether an integer or a letter. One of these bad boys is gonna catch. All right, give me a quick second to make sure we are still on track with the curriculum. We covered the views. We did all moves. Okay. We expanded on the endpoints. We got the converter. We were able to grab a specific Pokemon. Now we're gonna go back to our moves and elaborate a little bit more on the moves, just like we did on Pokemon. Awesome. So let's go ahead and close this out. We'll close out the Pokemon view and the URLs for Pokemon app. So we have the Pokemon URL. We can get all Pokemon or a single Pokemon depending on integer or string type. We have the moves, which is able to grab all the moves that exist within our database. But now let's actually add something in here. to grab a specific move, um, we can do path once again, and this time, we're gonna grab string, and this will be the name of the move. We'll call it move name, or single move. To stick to the same convention we did for Pokemon, right? This needs to grab a single move as a view, and it's gonna have a name of single move. And notice that I have an issue here because I don't have the move and it's not imported. I'll add single move here, and then let's go to our views for our move, and let's create that class single move. All right, who can walk me through the first part of creating this?
You're gonna go define your get method with self, comma, request, and name.
So it doesn't need, actually, it does need it. My bad. You're absolutely right, James. Wait a minute. It does need name. Uh, is it just name? Or what do we have to add here?
Maybe ID.
Not exactly. We called it single move, right?
Oh yeah.
It's gonna grab that that parameter from our URL. So if it's not called the same, it's not gonna grab it. You're gonna get an error. But you're on the right track. So we grab the single move. Okay. Now, someone talk me through actually doing this. We already seen it happen 3 times. I'm sure you guys have some of an idea now. Notice we're doing just string right now. We have no converter. We're not taking ID or string. It's just a string.
Whatever the name of the move was equals the class object dot get.
Yeah, we'll say we can do get object or 404 as well. So let's go ahead and bring it in. Get object or 404. We say get object or 404. We want to get it from move, and where the name is equal to single move. All right, so we have our single move. What's next? What do we do to this move? Yes, Owen?
In your single move line, you could wrap your all of that in move serializer, and then that serializes it. So that's one less line you have to do.
Correct. We could actually do that. That was the next step to serialize it. We did it in one line. And now, how do I return this, Owen?
You'd return response wrapped in single move.
Single move dot data, right? Because it's serialized. Let's test that puppy out. We come here. We have to change our endpoint. We will say moves, and then the move I want is scratch. And it didn't match any of these. Single move, name single move, scratch. What did you not like from my code? Ah, who can guess what's happening here? Let's see if you guys can debug this.
I think did one say it in the chat? Was it the closing caret or the closing greater than or equal sign for the path?
It is missing that. What else?
Oh, okay. Well, that was my guess.
That's one of them. That's one of them. Look at my URL path and look at the path I created on line 6.
Yeah, you're missing the dot title.
No. But that actually might be one too that we have to fix. Thank you, James. That's one I did not think of. Correct. It's very specific, guys. We have on the URL path here a // There's no / in my path. That's how very specific the URL path is. I have to add that. And now it's working. So the URL path works. Notice what's not working here is I'm getting a 404. So we fixed the first issue, the URL path, not actually making the request. But now we're actually not getting data back. It's making the request. We see here get, it made the get request. It even got a 404 response. Where is this 404 response coming from? James kind of already said it. It's not grabbing our move here. We have get object or 404, and it returned a 404. Therefore, it couldn't find an object with name to whatever my URL says. And that's because of the naming convention. So putting dot title there will fix our issue. And we now have Scratch. Do I have any questions on how to use the URL paths, how to get a single Pokemon or move, or all of them, or how to use a URL converter for our URL path? Awesome. Okay. Good stuff. We are doing really good with time right now, guys, which is pretty awesome in comparison to Friday. This video should be within like 2 hours and a half, no more. Now let's continue with the curriculum. So we have everything we want so far with our moves, guys. Our paths are made. We're able to get all Pokemons, all moves, as well as individual moves and Pokemons. So far, so good. The next thing that we will be talking about for today, and the last thing, will be testing our views. Right. So for our testing, there's a couple things that we need to do. First and foremost is we have to do a little restructuring of our files here. Let's go ahead and close some of these out. What we are going to do within the directory of your project, on the same level as everything else, I need you to create another directory. And this directory is going to be called tests. Right? In this test directory, we're going to add all the tests that we have created. In Pokemon app, I believe we have tests. This is testing our models, right? Creating Pokemon instance and creating them with incorrect names. These are model tests, right? So in my test directory, I'm going to create a new file that's going to be called test models.py. And I'm kind of cheating here, but I just want to get through this. I'm going to go ahead and I'm going to copy and paste these tests for my Pokemon within these test models. I'm going to have to fix some of the imports because now they're in different directories. So from Pokemon app.models, import Pokemon. And I'm also going to move the test for my models for my moves within here. So I'm probably going to have to fix the import too. I'm going to have to say from move app.models, import move. And then I'm going to come over here to my move app. I'm going to grab all the tests from here. And I can add them within here. Let me kind of separate this. Move model test. All right, so I got my tests for my Pokemon and my move models. The imports are good. I don't have any errors. Finally, let's go ahead and I'm gonna remove these. I no longer need these. And on my Pokemon app, I no longer need this because I now have it all consolidated with the test models.py. And before I start even making my other tests, I'm going to go ahead and kind of just test out how this works because the directories are different and it can be a little funny. Python manage.py test. Okay, it found 0 tests. So that's not working, right? Earlier before we were able to run tests and it just found all our individual test files, but now everything's within a specific directory. So this command can get a little finicky. So I believe it's test, and then you give it the name of the directory, which is tests, plural. And then we run this and we see here it found 4 tests. It ran all 4 and they were all successful. Right, so the way that we call the test is a little bit different. Now we have to specify the directory of where it's at. All right, so now that we have that, we are going to create a new test file. This test file is going to be called test views.py. All right. Now, let's go ahead and look at this. All right. So when testing our views, what happens? Well, honestly, when testing in general in Django, does your test use your database? Who can answer that question?
Yes.
It does not. It does not use your database. What actually happens when you run the test is the unit test creates an instance of a database, right? It creates a fake database, and it uses that database to run your tests. Once the tests are complete, it destroys that database and you no longer have it. Now, there is ways to change that setting so you can keep that test database to use it in the future, but by default, it automatically gets destroyed, right? But what that means is this test database doesn't have any data. We don't have any data to test it. So before, we were able to create our model tests, and they worked because what were we doing within these tests? We were creating the objects directly in there, right? It didn't need a database to check any real data. We made instances of these models within the test, and then we tested those models against these instances. So at no point has our test interacted with our database because it makes that instance of a database. It uses the instances we have created to use the test. For our views, it's going to get a little bit more trickier. Well, because the way that views work is they're supposed to test data that's within a database. So what that means, instead of creating instances like we're doing here, we are going to use our fixtures, right? We are use our fixtures as a way to simulate data from our database. Does that make sense for you guys so far? Awesome. So what we need to do is we need to create a file within our test, and this file is going to be called answers.py. And within this answers.py, we are going to add the answers to the test, or essentially the fixtures, right? So we will say, actually, let me take that back. This is not the fixtures. We are going to actually just create the answers of what the test should test against, right? We have our actual fixtures and we have the correct answers, and then we're going to check what it should be doing. So we'll create a variable here called a Pokemon. And then in here, I have to add the data for a Pokemon. So what I'm going to do is I'm going to go ahead and open up Thunder Client. I'm under the impression that you guys are familiar with Thunder Client. Is that correct? Awesome. Let me go ahead and run my server. I'm going to use this endpoint on my Thunder Client. And then I'm going to give it the endpoint for my Pokemon. I'm going to say API/v1/Pokemon. And then I'm trying to test with a single Pokemon. So I'm going to go ahead and grab Pikachu. and it's working. Now I can grab this data, but what sometimes happens is, if you guys are familiar with like CSVs, what do CSVs sometimes have and that you have to get rid of before you start working with the data?
Commas.
Commas, what
Headers.
else?
Header.
Not headers, not headers. There's something specific that you don't see here.
Oh, the space after.
Yeah, the spaces, new lines, right? And sometimes this can be very conflicting. So what we can do is use a command called curl, which we can type in our terminal and then pass in that URL, and we get back the raw data of what it should be. We can take this and in our answers.py, I'm going to add it in here. And it should work this way. So we have one for a Pokemon. Let's do a move, curl. Let me get the command for it, or the URL path. Oh no. Oh, this thing keeps getting in my way. Curl. And then, all right, I get it. I get it. We'll say moves, and then we'll say scratch. That gives me scratch. I can grab this. And I will add it with my answers. And then we're going to do one for all Pokemon. And then we'll also do one for all moves. Can you put past here? No, you can't. All right. Let's do moves. Oh, no. I'm sorry, this is being very annoying. Moves. We have this. This one might be a little weird. Let's see. We have Pokemon accuracy. Yeah, it's a little weird. I think I'm missing something here. Looking forward to this, husband. I see Gary. I think if I just remove this bracket here, I should be good. Yeah. Okay, we have scratch, so on and so forth. Okay, I think we got moves. And now let's do Pokemon. And I see, where is Pikachu? What if I do wrong? I'm sorry, this is taking a little bit longer than I thought. Okay, time is 11. While I fix this, go ahead on 10-minute break. I'll see you guys at 11:10.
Hey, Roger, on the README,
All right, so before we went on break, we were talking about creating our answers.py. One thing that I'm not quite exactly sure if I'm fully transparent with you is the naming of these answers. matching the related name of your endpoints. I think there'll be an issue here if we don't. But just for redundancy, it matches the name from my endpoints, right? Just so you guys are aware of that. But all right, let's go ahead and come back to the actual testing part of it. So I have a test.views. So let's go ahead and open that up. Not test.views, test_views. Now within here, there's a couple things I'm going to want to import. Well, first and foremost is test case from Django. So from Django.test import test case. I'm going to also want to import from Django.core exceptions the validation error. And last but not least, I have to import from my models from Pokemon app.models import Pokemon. And I have to import move from move app.models import move. There we go. All right. Actually, let me take a step back. We don't have to import our models. It's the answers we have to import. So from test.answers, right, the test directory that we created, I want to import single Pokemon, single move, all Pokemon, and all moves. There we go. Another thing that we want to import from test case, which is specific to views, is something called client, right? And client is going to allow us to make an instance of a client to simulate those requests that we're going to be making. And last but not least, we have to import something called reverse. From Django.urls, import reverse. These are the 4 imports we need. We need a test client, reverse, validation error, and the answers from our test. Next, we're going to go ahead and do our class. So class test views, which inherits from test case. And we can create every test that we want now. Going back to the discussion earlier about our database. So it creates an instance of our database every time that we run our test, but that database is empty. So we need to give it some information. So we have to declare a variable here called fixtures. And there is some magic here with Django. It's looking for the word fixtures in this test case, right? And it knows, and that's a very specific reason why we name our fixtures what we did. It's going to be looking for Pokemon data.json. And in the move app, it's looking for the move data.json, right? So in here in fixtures, we're going to do Pokemon data.json. You don't have to tell it where in the directory is it at because it's looking for the word fixtures. And then we do Pokemon. My apologies, not Pokemon. Move data.json. Right. So when it runs this test case, it looks at fixtures. I'm like, okay, you want some fixtures? You want specifically Pokemon data.json? Well, I got you. I'm looking for a folder in here called fixtures. I'm gonna check it to see if it's Pokemon data.json. It does. I'm giving it back. Same thing for move data.json. So it has the information for our instance of our database. Now we need a method called setup. Now this isn't unique to Django. This is very common for testing and using our client. right? Setup is a method that allows us to set up certain things every time our test runs. This is not a method that you have to call within any other test. It automatically gets called whenever the test runs. Within here, we are going to set up our client. We could do this without creating the setup method, but we would have to create a client for every single test we create. And this just sticks to the dry method of not repeating ourselves. So we do self.client is equal to the client module that we imported. And this creates an instance of our client. Notice here, a class that can act as a client for testing purposes. It allows the user to compose GET and POST requests and to obtain response that the server gave to his request. Right, so it creates like a makeshift client for us to use within the test. Now we have all the setup we need. We can create the test. We're gonna say define test 001 get all Pokemon. Taking self. And we are going to create a response variable. And this response variable is going to use our client and create a GET request. So we do self.client is equal to, I apologize, not equal to, self.client.get. If we didn't have this, every single time I start a new test case, I would have to do self.client is equal to client so and then use it. All this is doing is creating that data member, assigning the client to instantiate it, and then we can just go ahead and call it. It saves a couple lines of code depending on how many test cases you're making. Right? So self.client.get. This starts a GET request using this client, right? Imagine this is like an instance of like your React application. That's what this is doing. That client is starting a GET request. And what we are going to do in here is use this reverse method. What reverse does is actually very unique. It takes in a parameter. The parameter is the name of your view, or in this instance, it's going to be the name of our answers. This is why I told you I was pretty sure the answers need to be the same as our view name, right? So we use that. We say all Pokemon. So it takes in the data from the all Pokemon, and it also uses the view that we created for all Pokemon, uses that name that we assigned it. With that name, it's able to track what path it's supposed to use, right? It uses that name assigned to the path, and it reverses it from, it like almost does like backwards planning with it, and it grabs the path and how it should work. That's why the name is important for test purposes. We add all Pokemon in here. Once again, self.client runs, it creates an instance, right? That instance puts in a GET request, and it uses the URL path that comes back from the reverse method that's grabbing our view and answers. Cool? Everyone still with me? Awesome. Once we do that, we have to convert it into JSON. So we actually have to import something else up here, which is going to be import JSON. We need a JSON.loads that comes from the JSON module. And we do something like response underscore body is equal to JSON.loads. That lets us load whatever comes back from the response.content. Right? It grabs whatever comes back from the response. It grabs the content within it. Right? That content is whatever happens whenever this request is made. Essentially, what this is doing, guys, is the same as this, where it essentially does Pokemon, right? It grabs all this information. It has it within this response. What we are doing here is grabbing the content. Notice this, it tells you what type of content it is. It's application JSON, and this is the content. Right, we're grabbing that content from the response. And then what we have to do with that content is use something that you guys are familiar with already, which is the self.assert equal. Assert equal. Within here, we pass in the response body. And we want to compare it to what the answer is supposed to be from all Pokemon. Does everyone understand how this test works, line by line? I try to explain it as best as possible for every single thing that's happening here.
Can you just quickly go over how why you use reverse and like how that works?
Yeah, essentially, think back to when you use Axios and you use Axios.get. We manually had to put in like a URL path, add specific data in there, all these parameters. That essentially does the exact same thing. Reverse, what it does, it takes in an argument. One of the arguments is the view that it's supposed to look for. I have a hot mic. I'm not quite sure who it is.
Oh, that's you.
Oh, my apologies, Jacob. Yeah. It uses reverse to grab all Pokemon, and it traces that view through its URL path and grabs everything it needs to put in that GET request. So where before, when we were using the client, we had to put in our GET request, manually put everything in there. Reverse is doing all that. It's using the related name that's set to that view, to that path, to grab everything. Make sense?
Yeah, that does. Thank you.
No problem. Now, before I continue rambling on, let's test it out. If I have 5 tests and I failed, and I already know why it failed. It says list differs, right? This is what it was checking, and this is what it was checking against. And obviously, look at the spaces. You see how it's in a weird format. My all Pokemon. That's because I copied the information straight out of Thunder Client. It does not like that. We might have to. I didn't want to do it because it was giving me such an issue trying to grab it. Curl. I have to start my server. It's not liking the answer. It obviously matches, but the format is not there. There's unneeded spaces and breaks, and that's exactly what I was trying to get to when I was explaining to you guys that it's not in the format that's looking for it. Here we go. This is a much better. Oh, here we go. There we go. This should work now. So much better. I don't know why I wasn't doing this in the first place. Oh, Pokemon. Okay. Let's go ahead and try that again. If it doesn't work, then obviously I did something wrong. Test, file 5 test. It failed 1. It's still not liking it. Second list contains 1 additional element. Rock Smash. First different element is this ID name, Scratch, Pikachu, 29 characters. I don't know if my fixtures, maybe they're outdated. Let's look at my fixtures. And let's look at my. Let's run the server. Get Pokemon. And Yeah, it's outdated. Notice how the first one I have here is Squirtle, and then over here it's Pikachu. And that's because I've been making different versions of this project, constantly getting new fixtures, dropping database. So my fixtures do not match. Unfortunately, what I could do is either just copy this, or I could just download new fixtures, which is the right answer. Yeah. Okay. Yeah, the right answer right now, guys, is for me to dump data into this. As a matter of fact, let's do that. Maybe it's a good recap for everybody. How can I go about dumping that data into my Pokemon app fixtures? Who can talk me through the command? Nobody. I'll start us off.
Manage that pie.
Right
Dump
on.
data. Dump data into your
Dump data.
app.
What data do I want to dump? Pokemon app dot Pokemon indent 2. And I want to dump it into Pokemon app fixtures Pokemon data.json. Let's see if that works. First try. Let's go. First try, baby. All right. That fixture updated. So you saw me do it. Notice it changed drastically. All right, someone else. How about for my move app? Chances are it's probably not updated.
Python, manage that pie, dump data, move app.
Dot move.
Oh, down, sorry.
It's okay. What's next? We use indent 2. And then I want to dump it into move app slash fixtures slash move. I want to say it's move or moves data. Move data. Move data.json. There we go. It should be done. All right. So that was a good warm up review. Let's run it again. File file test, and it's not liking it. Okay, I'm not quite sure what's going on. It's not liking it. I can see it's testing it, but something's differing. Second list contains one additional element. See how this is ID 1 scratch? No. Okay. I'll come back to it. There's something up with my data that's not liking. I don't know if it's the way that I have it. I think maybe it's the list. I don't think it's a list. No, it failed. It did not like the list. Or the fact that it didn't have a list. Get all Pokemon. Alright. Well, I don't want to waste time without talking about the other test. I have to debug my code to ensure that I can fix what's wrong with my stuff. This is like the 3rd or 4th version of this project, so I'm not surprised that not everything is smooth, but that's okay. We can go ahead and move forward and ensure that we get what we need to get by the end of our time. So we have get all Pokemon. The next thing we're gonna do is test 002, get a Pokemon, taking self, just like before, we are going to do response is equal to self dot client dot get. It's gonna use reverse. And just like before, we're using the name of a Pokemon. Actually, it's gonna be single Pokemon. This time we're gonna add something different. We're gonna add another argument or parameter, and it's gonna be args. Right? This args is going to reference what else is supposed to be in my URL path. And we already know that get Pokemon, right? A single Pokemon, it does take arguments. It takes a Pokemon ID or name, right? And for this instance, I'm going to say I'm trying to grab Pikachu. So when it does the reverse and it grabs the URL path for a single Pokemon, it's also going to take Pikachu as an argument and add it into that URL. We'll do response body is equal to JSON.loads, get the response.content, and do self.assert equal, and pass in the response body and a single Pokemon. Let's see if this one works, man. It worked. That one worked. It's still failing the first one. There's something wrong with my all data Pokemon. My all Pokemon data. This test worked. It did not like this one. There's something up with how I have all Pokemon. All right. Let's go ahead and continue. That takes care of the get a Pokemon.
Yeah, is it supposed to be equal or equals? Like on 31 and 22? You have assert equal on 22 and you have assert equals on 31.
That's a good question. Assert equals, I think, is that what was going on? No, I don't think it is.
No.
He needs to fix his life. Fix yourself. All right, so that tested my views, right, for all Pokemon and getting a Pokemon. Now let's test my endpoints, and then that would be the end of class. So we have models, we have views. We're gonna create a new file, and this is gonna be test endpoints, or should I say test URLs? We'll say test URLs. Test URLs. We have to import Django.test, import test case from test case. No, from Django test. Sorry, it's been a long morning. From Django.test, imports test case. There you go. We're also going to import from Django .urls, import reverse resolve from Pokemon app.views. Let's import all Pokemon and a single Pokemon. From move app.views, import all moves, and I believe single moves what we called it. There we go. We are going to create our class. It's going to be called test URLs. And it's going to inherit from test case. We're going to define test 001 all Pokemon. Then we are going to create a variable called URL. All right. Then this URL is going to take in a command called resolve, which I just imported. All right, let's hover over it. Resolve essentially uses your URLs and checks the URLs. It's not using a client for this. Best way to explain it is it's kind of like testing the endpoint to make sure it exists, if that makes sense. Right? Where the client was trying to receive information, which was done within a GET request. So we needed self.client before. Here, we're just trying to make sure that the URL is actually doing what it should be doing with our view. So resolve does as such. It uses the URL path. You can even see their URL config, I think is what it's called, for the path. All right, I'm going to say reverse. And we are looking for all Pokemon, right? All Pokemon. Where's my URLs? We're looking for all Pokemon, right? It's testing the URL path. It's looking for all Pokemon. This is no longer checking the answers or anything like that. It's looking strictly on the name. This is strictly on the name assigned to the path. Right? So we do all Pokemon. And then we do with subtest. And what subtest does is allows us to run more than one assertion within a test. Are you guys familiar with test casing or test cases? I believe you guys got an intro to them in like Flask and stuff. Is that correct? No? Okay, I see Juan, yes, kinda half. Owen, acting like he didn't go through FOP with me. But all right, yeah, so we're gonna use with subtest, and what subtest is gonna do is allow us to do multiple assertions. Right? And within the subtest, and this one, we are going to do self.assert equals. We are going to check the URL.route. And then very specifically, we are giving it what it should be. API/v1/Pokemon. Right? It's asserting that whatever URL path it got from the all Pokemon path is equal to what it should actually be. And then outside of that subtest, we'll give it the second test, which will be self.assert true. And then we say URL.func.viewClass. What this is going to do is it should grab that URL, the function that's assigned to it, and then it's supposed to take in a view class because it's a view. And then we say is all Pokemon. So this one checks the URL path is what it's supposed to be. And this is checks that if the second argument, which is supposed to be the view itself or the function, is actually what it's supposed to be, right? Make sense? And then you would do the exact same thing for every other endpoint, right? Only difference is you change this for like all moves. You give it the all moves endpoint, and then you pass in the all move view. My bad, stuttering a lot. You'll give it the all move view or function, whatever you decide to do. Please don't fail. It did not fail. Let's go. Still, that all Pokemon one for my views does not want to work. So it worked well, right? It did not fail. It's still failing the get all Pokemon for my views, unfortunately, which I will fix. Do I have any questions on testing your URLs or your views? I want to go back to test views and reiterate on this. I don't believe, because I was a little confused at first. I don't believe this tests the view. I think because we imported specifically the name of the answer key, we could change this to like a Pokemon and a move, just like the curriculum has it. And it should be good. Pokemon, single Pokemon. Yeah, there we go. Right, this is looking for the answers. All right, we didn't import any models in here. We imported the answers, and that's what we are using to test. Whereas for the URL test, this is actually looking for that name that's in the name of path. Make sense? Because we also imported the view itself, right? We're testing the URL path while this is testing specifically that the view does what it should be doing. Before I stop the recording, do I have any final questions? Speak now or forever hold your peace. All right. I'm gonna go ahead and stop the recording now.